All right, welcome everybody. Thanks for joining us today. Hope you've been having a good week here. As a quick introduction, my name is Krishnan. I work in AWS Seattle. I manage engineering teams in AWS LAMBDA. Prior to LAMBDA, I was leading SimpleDB and DynamoDB storage. And prior to joining AWS, I was the co-founder of a company called LiveMocha. And I'm thrilled to have Yvonne join me here today. She is a software architect at Financial Engines, who are a big customer of us. And we're going to be talking about troubleshooting and monitoring serverless applications. So we'll look at a application, we'll look at what it takes to build one and troubleshoot and monitor it. And Yvonne is going to walk through some of the use cases from their company. Okay. I thought it would be useful for us to take a real-world application and follow the story of that application and see how they build it and how they would maintain it and troubleshoot different issues. And the application for us today is Molly Moo. It's a startup that's going to deliver lactose-free milk to celebrities. The founders evaluate the idea, think there's a huge opportunity, and decide to build a company around that. And they think it's going to have a couple of key components. It's going to do there's going to be some key AI components to match if you're a celebrity. And of course, all the investors told them you have to have something with AI to get funded these days. And they also think that the application will need to scale pretty quickly, especially during emergencies if there is a huge spike in order volume. And having come to reInvent, they get super excited about AWS and like the rest of you about serverless and decide to build their application with AWS and serverless. So as all of you know, serverless computing is about building your application without having to think about servers. And as all of you know, there are servers running behind the scenes. And why does this matter? Right? When you think about computing over the last decade, we've moved from having physical machines and data centers with lead times in weeks to the cloud, where you're now able to programmatically, to a higher level of abstraction with APIs, you're able to provision and deploy large fleets. However, you're still having to think about the servers that you're using. You're having to think about the scale. You're thinking about your peak to average ratios. You're thinking about what it takes to maintain those machines. And you're paying for idle time, right? And so our customers, a lot of our customers asked us to make things simpler for them. They wanted to be able to run code without having to think about scale, without having to think about provisioning or placement of that. And they didn't want to pay for any idle time. And many of them were building a lot of code to talk to other AWS services, and they wanted something that would be more simpler for them to use. That led us on this serverless journey. And a couple of years ago, 2015, we launched AWS LAMBDA. And LAMBDA is a compute service that lets you run your function without having to think about where it's running and thinking about scale. We do the scaling for you automatically. You don't have to manage any of the servers. You're paying only for the compute that you consume, and it's on a per-request basis. And we automatically scale for you on the back end. And we also bill you at a sub-second metering, so you don't pay for any idle time. And you can use LAMBDA in a lot of different ways. One of the ways that a lot of customers use it is in event-driven computing. In event-driven computing, there are three big components. The first is the event source, which generates the event. So, for example, this could be an S3 bucket. You could have a file in it, and you would have some code that is reacting to that event. And so LAMBDA is a great model for that, because you can now hook that LAMBDA function to be triggered when that happens in S3. And you can write the LAMBDA function in a lot of different languages. And the LAMBDA function can then in turn around and talk to other AWS services, right? So this is great. So it lets you build your application in a largely go from a monolithic application to a decoupled set of microservices. And a lot of our customers and Amazon internally, we moved to a microservice architecture. So that's great. So let's go back to Molly Moo and see how they would build their application. So in this case, they've decided to use LAMBDA and a couple of other serverless components. So they're going to be storing their state in DynamoDB. They use LAMBDA, and then they're using a new Amazon AI service called Recognition that lets you match celebrities and then store state in Dynamo. So this is their architecture. Let's look at how they would be able to build and maintain this application, right? So with this, and this is great. So we went from a concept to an application, and you didn't have to think about scale, and they were able to build a architecture pretty quickly. This new model does bring some new challenges. Unlike your hosted model, you don't have the ability to have agents on these in Lambda, for example. You can't have your own agents that are doing monitoring. These resources only exist during the time of the execution of the function, collecting logs across lots of different services and aggregating them in real time without any performance impact can be challenging. And when you have a lot of microservices, it becomes challenging to correlate across all of these services. And so when your application goes from something simple like this to something more complicated, it becomes more challenging for you to have to monitor and troubleshoot issues in your application. So in today's talk, we're going to focus mostly on what you would do to troubleshoot and monitor in production. But just as a general call out, there are a lot of things that you can do locally and before you deploy. So you can test your functions locally. We have SAM local that lets you attach a debugger and lets you debug your code before you've deployed. And with the Cloud9 announcement that you saw today, you can do debugging before you deploy. And then with code deploy and with the blue-green deployments that we just announced, you can do a lot of things before you actually deploy the code. In this, and there are sessions for that, and I would recommend highly checking out those talks. Today, we're going to focus mostly on troubleshooting and monitoring in production once you have your application deployed. So going back to the sample application, right? So when you build an application like this, and even for many of the services internally in AWS, one of the things that we want to do is you want to create metrics and dashboards and alarms, right? When you want to be alarmed, and you want to, when things go wrong, where you want to be paged, you want to have alarms, you want to have metrics. And when something like that happens, we get paged, and then you go in and look at a dashboard, and then on the dashboard you see different metrics. You're able to drill down, and then you can then go look at certain set of logs. And it would be nice to have the same thing in a serverless world, right? And then you should be able to pinpoint different services, and then which are having failures, and then be able to troubleshoot your issues. So let's see if we can do that in this for this application in the serverless world. So let's take a look at LAMBDA. By default, LAMBDA has integration with CloudWatch logs, right? So anything that you have the ability to log to CloudWatch. And by default, we log the start and times, and then you will have a log entry for the report as well, which tells you what the duration is, how much memory you took. These logs are automatically sent to CloudWatch. You can also add additional logs to it. You can by using the equivalent of console.log, for example, Node.js, you can add additional logs. The nice thing about this is the agent is running outside your code, and therefore there is no latency impact to your application, unlike other systems where you have to log it directly. And then these get bashed and sent to CloudWatch logs, and they are available for you in real time to see. Going on to the metrics part, LAMBDA natively integrates with CloudWatch metrics. So we collect a default set of metrics for you, and those are available for you to see both in the console as well as in CloudWatch metrics. And by default, we were tracking 6 metrics for you, including invocations, durations. And today, we've added a new metric, which is the per function concurrency. So now we have the ability for you to be able to limit the concurrency or set concurrency limits for different functions in your account, and then have metrics on those, and you can even alarm when something gets close to its concurrency. And then you can then, once you have these metrics in CloudWatch, you can then create dashboards and alarms, and then you can have this notify you if there is an issue, right? And then you can always add more metrics by adding through your code. You can put directly to CloudWatch, right? What if you want more than just that, right? These are the default set of metrics that you can create dashboards and alarms. What if you want more? A simple way to do that is by emitting logs in a certain format. So you could emit it in a format, and then CloudWatch allows you to create metrics based on filters. So for example, if you want to track, for example, cold starts for your application, then you can have that be logged, and I'll show you how you do that in a little bit. You can log that, and then you can then have a filter in CloudWatch that then lets you create a metric around it and then create a dashboard for that, right? And then in addition to that, you can always use third-party tools. There are a bunch of them that you can use to do better log aggregation and visualization. For example, in this case with IOPipe, you can wrap your code with some functions, and then they have, using the token that they give you, you can go and visualize this on their dashboard, right? Okay, so let's look at how, so I'm going to jump to the application now and try to show you how it's done. So let's look at Mollymoo and see how they've done this in practice. So this is the, I'm going to the, they have a set of functions that we've defined. The key function is the one that recognizes that you're a celebrity. With the new console now, with the Lambda console update that you will see, you can attach different triggers, all of that. There's a function designer in the console that you can use. And then there is a new IDE within the console. Both you can use it in within this, and then you can also use it in a full screen mode that you can use to edit your functions. So just going back to that example, you can add different logs. For example, in this case, I wanted to log something for cold start. So I can add a log line when I see a cold start and have that go to CloudWatch, and then I'll show you how to do a metric around that. The other thing that you can do from the console is once you have the function, we provide you the default set of metrics. You can then, for Molymove here, and then you can go in to CloudWatch and view those metrics as well. So let's go into CloudWatch. And for every function, you have a different log group, and the logs are aggregated for that log group. So this is the one for the Molymove celebrity one that I'll show you, and then you'll see all the log entries for that function. And you can click on any of these log entries. You can see the different logs that are automatically being done. These have an additional set of logs that I've logged. By default, you can also see there's the end and the report, and you can do a bunch of different things with that as well. So let's look at the metrics. So again, we do track a number of metrics, and you can, for your function, for example, invocations, durations, and you can look at that, add those to your dashboard if you want, right? And then let's see how you would create a custom metric, right, if you want to do that. So let's go back to your functions. Okay. So if you go back to your logs, you can see the different functions. You can create a new filter for your log. When you click this, you can add a new. Here I'm created a new filter for the log for the cold start. So we added a log line for cold starts, and that's getting emitted. So based on that, I can create a filter expression, and then I can create a metric around that. So I can create this. In this case, I've created a filter expression for that, and then what I do is then create a graph for that, and then I can add that to my dashboard. So let's look at how the dashboard looks like. So I've created a dashboard for my application now. So I'm tracking a bunch of different metrics. So the metric that I just added with that log line cold start, I've added it to the dashboard, and now you can see, and I've also created an alarm, so you can track how many cold starts I've added. I can alarm myself if something happens. By default, I've also added some of these other invocations and availability metrics to my dashboard here. So this is things that you can easily do automatically. Right? Okay. So let's go back to the application. So this is great. So they've got a basic set of metrics going. They have a dashboard. They're able to get alarmed. They get paged if there are issues, and they can go in and look at different things that are happening. So they now get paged about a customer issue. Looks like this customer is not getting their deliveries. So one of the challenges with the CloudWatch logs was that your logs were getting aggregated by function group, right? So by a log group. And so it might be challenging to search across all of those log groups. And in order to, especially to troubleshoot some of these customer issues, you want to be able to search across all of these logs. You want to be able to, even better, if you have something to be able to search per customer, if you can create per customer metrics, that would be easy to solve some of these issues. And luckily, it's not hard to do that with what we have. So what you can do with LAMBDA is, by default, your logs are going to CloudWatch logs. And so you can emit these logs in a certain format. And you can have a custom format for those logs. And once it goes to CloudWatch logs, you can have a LAMBDA trigger that basically that gets triggered when these logs appear. And you can have a filter that, for example, this LAMBDA function could get triggered only if there is an error, right? And so you can have that LAMBDA function get triggered by that error, and then it can parse that log, and then it can do one of two things. It can send that to another service, for example, Elasticsearch, or it could also emit another metric back to CloudWatch metrics again. And so by sending this to Elasticsearch, you have an option to go visualize and search across Elasticsearch. So in this case, for Molymove, here's what we've done. We've basically have a sample function. So I wrap for any time we have an error in the application. Instead of directly doing a console.log, I have a wrapper function that's basically logging the error, and it has a certain format, and this is the format I've used. Essentially, that's going to create the log line in CloudWatch with this log entry. And then the function that is getting triggered is going to get triggered only if there is an error in the filter expression. And then what happens is that function then publishes this log to Elasticsearch. And then we can search in Elasticsearch with different plugins. So I'm going to show you how you do that again. So let's go back to, so I've logged the line. So as you can see, I have a log line, and anytime I have an error, I essentially go and log the error there. And then we have a function that is basically getting triggered by the error. So you have this function log processor that has that is basically a trigger for this event. And so you can see that CloudWatch log is triggering this function. And then let's look at the function quickly. So the function is pretty straightforward. It's looking at the log line. It basically parses this out into its fields. At that point, in this case, it's basically publishing this to Elasticsearch, and you could choose to do this to another service. You can also publish another metric, as I was saying. So this case is publishing to Elasticsearch. And let's now go back to Elasticsearch and see if we can figure out what the issue is, right? So I'm going to go back to Elasticsearch. I'm going to search with the customer, see if I can figure out what's going on. OK. So that's the log entries. So it looks like there's something wrong with the image, and it's not being recognized as a celebrity. So let's look at the image. Maybe there's something wrong with that. OK, this is a fairly old picture of him, so I'm guessing it's not getting recognized as a celebrity. So let's go back to the function. I'm going to try to see if I can fix this on the fly. I'm going to force it not to use force it to use a later image, not the older image. So let me use the latest image here. I'm going to save this. So one of the nice things about the console now is that you have this full screen mode that's helpful in terms of doing quick edits and saves and iterate around that. So let's, and again, here for the log error, what I've done here is use a format. You can have different formats and then use different functions there. So let's go back to this and see if this works now. Oh, great. So now it's able to detect that it's working. It's able to detect the image. It's using a different image, and it's able to detect that he's a celebrity at this point. OK. OK, great. So we've resolved that issue. OK, great. So the customer is happy. You've resolved the issue, and the company is doing pretty well. And after this endorsement, they end up raising more money, and then the traffic continues to grow significantly. So when you have a smaller, so let's look at, so we've done a lot with logging and just metrics, right? We've been able to troubleshoot issues, and you can do a bunch of things with logging. But as your application starts to get more complicated, it gets harder and harder to do these things with just logging, right? So when your application looks like this, where you have API gateway and a function and Dynamo, you can add more logs, and you can basically correlate the logs that you have from API gateway and DynamoDB. And by timestamp, you could do some matching and then troubleshoot your issues. You can also add a lot more logging information around the calls to DynamoDB. But as your application starts to get more complicated, it becomes harder to do this. So when it becomes like this, it gets more challenging now to correlate across all of these services. You have to do a lot more logging. It gets harder to do it across timestamps across all of these applications. And the real challenging thing is that as these applications grow bigger, you can have a service that is five hops downstream that fails, and then it gets harder to figure out which service is going wrong and how do you troubleshoot that, right? And you have to be able to correlate across all of these different services, and that's not easy to do with just logs, right? And what you really want is something like this. You want to be able to look at your application in what we would call like a call graph or a service graph, and be able to track that how the requests are going through your application. You want to be able to start from your application, look at the different components and the different nodes in your system, and be able to and know if something is going wrong. And in this case, if one of the nodes has an issue, then be able to and it should flag it for you. And luckily for us, we have that. We have a service in AWS X-Ray, which was launched earlier. And X-Ray basically tracks traces through your entire system. So they collect data as it goes from the different components. So as it goes from service to service, you're collecting data, which is then aggregated into a trace, and those traces are basically for your service call. And X-Ray does all the work of combining that to present that for you in a visual format. Right? And this allows you to pinpoint issues in your application much more easily. So you can identify performance bottlenecks, you can identify issues, and you can pinpoint and troubleshoot those. And with LAMBDA, X-Ray is natively integrated. So we have an X-Ray agent that's already running, that's collecting logs. And in your LAMBDA function, you can turn that on by turning tracing on, turning it on, and then that automatically tracks the trace for your LAMBDA application. And so it starts to collect metadata and as well as to calls to the other service are also getting logged. And this happens in real time. There's very low latencies. There's no impact to your application, and this data is getting logged. You can usually see the traces in a few seconds immediately. And this enables you to get started doing what I was just showing, the service graph, without having to do a lot of plumbing in your application. You just have to check a box saying, I want tracing on, and your Lambda or your serverless application now has tracing enabled through the application. And this is how the raw data looks like. X-Ray, as I said, the X-Ray is tracing the request through and collecting data as you go from service to service, and each of the services is called a segment. There's data here that it collects. There's a piece of data that identifies your segment. It tracks the time that it's spending in that segment. It tracks the outcome of that segment. If there's an error, then it tracks that, and if there's success, it tracks everything. Everything is correlated with a trace ID, and that's how they're all correlated. And then it also tracks other components like the origin and the of your trace, right? And the resources that are used. And what X-Ray does for you then is, with that raw data, it provides you that data in a visual format. By default, it shows you in your service map. When you go to your function and you look at the service map, you're going to have 3 nodes. The main application will have a node, and that you can look at that node, and then it has the time that is being spent in the Lambda function, and then a node for any downstream call. So it's basically visually showing you the data, and it allows you to drill down. So you can look at any of these nodes, and you're able to drill down. And when you drill down into one of these nodes, first of all, you can see the service graph, and there are different colors there. So in this case, some of these nodes have an orange color. They're indicating there were errors for that in some cases. You can click on any of these nodes. For example, here you can click on the recognition node, and you can then click on the errors, and that lets you filter all the traces that have errors. So this is really cool. So you can start from a service map. You look at your service map for your application, and you have the service map, and let's say there are 2% of them are errors. You can click on the errors, and then when you click on the errors, it'll show you the traces for those errors. And so now you can go into each of those traces. You can now start to understand the performance and the errors for those traces. So in this case, let's say you went into one of those nodes, you clicked on the trace, you clicked on the errors, you clicked on the trace. You can then go to the trace. You'll see a list of traces. Once you click on that trace, you can then go into the performance characteristics of the trace. It shows you the data visually. It organizes it by subsegments. You can go into each of these subsegments, into these segments, look at the time being spent on any of these, and if there are errors, it'll show you that there is an error in one of those, and you can click on any of these. You can see the errors there as well. Right? So this is great. So here's some of the concepts in X-Ray. Right? So I talked about the trace in X-Ray that you can basically use to aggregate all of these segments with. Each part of your each service is aggregated into a segment, and that's happening for you by default. But in addition, you can create subsegments in your trace, and so you can do that by adding. When you add a subsegment, you're creating a subsection in your trace, and you can track different characteristics around that subsegment. Right? You can also add other things like annotations and metadata to that trace. And the reason you add an annotation is that you can then go back to your trace and you can search for those with an annotation, as I'll show you. You can search for annotations that have that, and then it helps you debug requests that have that annotation. You can also add other metadata that you want to be available, and as I showed you, it shows you errors as well. And so X-Ray provides you a set of API that you can then use to filter this data. You can use that to aggregate this data. You can also use add additional subsegments. You can add additional annotations. In addition, what you can also do is you can use the API to put more data in. So you can add trace segments. You can get those trace segments out, and then you can do a bunch of different things with it. For example, you can take the raw data out into another application that can analyze this for you. You can take it into another application that lets you visualize it differently. You can trace it differently, and then run different kinds of search there. So in this case, you would use the default the SDK. And then what you can do in this case, what I've done here is basically I've added a subsegment here to track as I start going through my function. Once you add a subsegment, it creates a section for you, and then you can start to add different things like annotations to that trace. And when you add a subsegment, what X-Ray then does is it basically creates subsegments for you. So in this case, you'll see when I've created different subsegments, or for my calls for Dynamo, it's creating subsegments that then I can then look at each of these and say what the issues are, and I look at the time that is being spent in each of these subsegments, and I can drill down into any one of those and look at performance issues. Right? So Let's look at the other case. So you could also, in the previous case, when we had the issue with the celebrity image detection, and we used Elasticsearch to do that, you can also do that with X-Ray. So for example, when I had an error with the recognizing the celebrity, I could have added a annotation in my subsegment. So I could say this was my error. And then what that does is it logs that data to X-Ray. You'll see that in the raw data. You can then go into X-Ray in the X-Ray console, and then you should be able to search those annotations. So in this case, when I had the previous error, I could have searched, because I was adding an annotation that said error, I can do annotation.error and then search for the string that I just added, and it'll show me all the traces that have that error in it. So that's pretty cool. So as you go through your function, you can add different types of annotations, and then you can search for those, and then you can go into any trace that has those annotations, allowing you to drill down into those annotations. So in this case, these are all the traces for when we had this error with recognizing that celebrity. And so when I can click on one of those traces, I can go look into the raw data, and I can skim through it and see and if I've added more annotations or I have more data that is being logged, then I can look and see why that's an issue. And in this case, it looks like it was not being recognized as a celebrity. So this is another way that you can go look at it. And this is, what is interesting about this is that if you can add annotations and other things that you can do with X-Ray, then you can drill down into those error conditions and then start to drill down from there and then do this versus having it into another system. Okay, great. So we've gone through a bunch of concepts with X-Ray. Let's see how we can tie that all together. As the application is continuing to grow with Mollymoo, a lot of the users start complaining about performance issues. And as the traffic has grown, their performance is getting slower. Let's see if we can use X-Ray to debug this. Right? Cool. Okay. So I'm going to go back to my application. So the first thing you want to do when you have something like that is go to your dashboard, right? So let's use the dashboard that we created earlier to see if there is something that it signals, right? So I'm going to look at the cold start. Doesn't look like there's any issue there. There doesn't look like there's any issue with the invocations. The only thing, there doesn't look like any availability issues. There are not any different errors. The only difference that I can see is the number of concurrent executions has increased, and the function duration seems to have increased. But at this point, it's not clear what the issue is. And so now let's see if we can use X-Ray to figure out what's going on, right? So let's go to the X-Ray service map for this function. So as I was saying, you can go back and create a service map. Sorry. Let's do it for the last 2 hours. So you can go create a service map for your application. It's going to go through those traces. It's going to create a service map for you. You can look at any of these service maps. Like I said, if you click on one of them, you can see the different distributions. You can click and filter based on the errors. So let's look at the service map. In this case, I have the main function that is being called that calls the Mollymoo celebrity lambda function, and that's turning around and calling the recognition function. And the bulk of the time, the function is taking about a second, and the bulk of the time is being spent in the recognition function. Right? So let's click through to find a recent trace, go back in and find a recent trace. Let me do this for the last 1 hour. And then let's click on one of them, see where the time is being spent. So that's a nice way. So in X-Ray, when you find a trace, it gives you a visual representation. There is raw data here that you can go look at. If you want more data, you can look at your timeline here, and let's drill down into the timeline for this application. So we have the main application here, and then there is data here that is tracking the amount of time that is taking. The first call that it makes is to get the status of the application from the cache that I have. In this case, it's a DynamoDB entry. It's returning from my cache, and then it's going to recognition to determine if it's a celebrity or not. Okay. So let's look at another trace to see if there's anything different there. Yeah. Okay. So let's go back to our application, try to run a test, and see where the time is being spent, right? So I'm going to pick a different event. So with Lambda, with the new console, you have the ability to configure and test your events right here. So I'm going to pick an event and then try to test it. This should now generate a new X-ray trace that I can go look at. So let's go back to, so this is run. It's taken over a second. Let's go try to find a recent trace. It's always risky when you do this real time. But as you can see, the trace shows up in a few seconds there. You can now, let's see if we can figure out what's going on there. So you see it's tried to make a call for that image. It's looked up in its cache. It then makes a call to recognition, and then it tries to put it into the cache. The put cache call this is a subsegment that I've added for put cache, and it's showing up, and it's barely taken any time to put it in the cache, and it's going to recognition. So the issue, I think, is, and bulk of the time is being spent in recognition, and clearly we want to be able to cache that data. And so here we've added, we are adding it to a cache, but it looks like, the add call was really quick, and then the get call seems to be failing, or at least not finding it in the cache, and it's going to recognition all the time. So let's see if that's the issue. Let's go back to my code. So as I was saying, we first look at the data in the cache. If we don't find it in the cache, we're going to go into recognition, make the call there. And then if we find it, we should be adding it to the cache, and we have an annotation which basically adds it to the cache that you saw. And it looks like we are not putting it into the cache at this point. We would turn it off for some reason and then forgot to turn it back on. So we're not putting any data into the cache. And if you look at my cache, which is basically DynamoDB, I'm not finding anything in the cache. And as a result, it's the get call is not returning anything. It's going to recognition. So let's see if we can fix that. So I'm going to turn this back on. I'm going to save this. So the nice thing about this is that when we, with the Lambda console, is that you can save, you can do the test, and we also have the ability for you to see the results within the console. So this is a new addition to this. We have the new Cloud9 IDE that has been integrated. As you saw, we have multiple ways to use it. This is in the full screen mode. It's built so that you can iterate and test pretty rapidly. So in this case, I've added it to the cache. Let me test this again with the same test event. So in this case, it should take time because it's not in the cache. But at the end of this call, hopefully it should have added to the cache. Let's see if that did. It did take the same amount of time. I'm going to go back to X-Ray. Go back to the trace. Oh, maybe it's not with the annotation. Okay. Okay. So it is taking a second still. So let's see if we rerun this. It should have added it to the cache. Okay, great. So now it looks like it's found it in the cache. Let's see if we can pull this up with X-Ray. I'm going to remove the annotation. So there are the traces that have shown up. That's in real time. So let's look at the most recent trace. And as you can see, the previous trace was taking us 2 seconds, and now we've reduced that to in the hundreds of milliseconds. So using this, now you can see that the get cache has succeeded, and the entire call went through far more rapidly, right? So we've been able to put in the cache, and then we're able to get this, and then it doesn't make a call to recognition at this point. So that's great. So we were able to use X-Ray to be able to debug this on the fly and fix it here. And you can see this in the execution results as well. We are adding it to the cache, and you can see the time has been reduced. Okay. Okay, great. So we fixed that issue, and then, and the company is doing pretty well at this point. If you fix most of the issues and they decide to go public. So at this point, I want to introduce Ivan, who's going to talk about how they use X-Ray and other monitoring tools in financial engines and walk us through some use cases. Welcome, Ivan.
Hello, everyone. Good afternoon. My name is Yvonne Roberts. I work for Financial Engines as a software architect. So with roots in Silicon Valley, Financial Engines is the nation's largest independent investment advisor, and we believe that all Americans, not just the wealthy, deserve high-quality, unbiased financial help. Today, we offer financial help to over 9 million people across more than 700 companies. So to support those 9 million people, a few years back, we decided to step back and change our strategic approach to how we wanted to grow our tech infrastructure and move to the cloud. We had a monolithic code base on-premise, and as you know, that gets a little hard to manage and to scale out. And this move would allow us to scale more efficiently, cost-effective, and such. So we had one team, their goal was to focus on a lift and shift approach and taking our tiers and moving them one by one onto the cloud. And then we had the rest of our team that was working on taking little pieces away from that monolithic code base and creating microservices, specifically with a serverless architecture. And we have a very high bar on using non-managed services. Today, we have about 15 microservices in the cloud, with some of our core engines apps getting, for example, 300 million invocations in a given month. So when we started this journey, we said, okay, what do we need to do? What do we need to measure and determine as we made it to say that this is successful? So we had to measure performance improvements to compare, Lambda services against our, beefy racks and make sure, okay, this was a good decision, we're doing the right thing. We had to do ongoing measurement of performance so that when engineer X made change elemental P, that he wasn't affecting performance or degrading performance. And we also needed to be able to identify and resolve issues as soon as they came up. So how did we do this? We first started very basic. We took our code, we instrumented it, and had calculations on how some of our key methods, how long they took. We would add it to the end of the log. We also created stress test applications that would take invocations, let's say from production, and run that against our applications in dev, and then take that log that we had written to and make calculations and statistics and say, okay, this is how it's performing, this is how function XYZ is performing, and compare that to production on our beefy servers, for example. We also have CloudWatch and Splunk dashboards, and I have alerts. So if anything spikes too high, if performance is starting to take a hit, we know that right away. But that still didn't give us the big picture. That still didn't tell us the customer's journey, for example, through our microservice. We knew, Lambda took about this amount of time, but we couldn't say, this amount of time is spent on DynamoDB, this amount of time is spent on S3. And so what we did was this past summer when AWS released X-Ray for Lambda, we decided to give it a spin and see how that worked out. And it was actually pretty good. We got pretty quick wins almost immediately. To implement it, it didn't take more than 20 minutes tops. And we were able to push that in production and right away see subsegments and segments and get performance numbers. It was a sampling of traffic, obviously not all of our traffic, but it was good percentages. You got transactions per minute, average latency, and distribution. And we were able to, with that, be able to see, okay, this part of our code is not performing well. We need to either add caching, or we need to do some Lambda fan out, or even change throughput, for example, on DynamoDB. And we were able to get better numbers, for example, on different invocations. So we're a fintech company, of course, and every person, we give advice to every person, no matter what type their account is. But a person with one account versus a person with 20 accounts, the performance on some of our Monte Carlo simulations, for example, can be drastically different. And also, some companies may offer stock options, other companies may offer pensions, and that would also change how that simulation would work. And with annotations, we were able to see, okay, specifically for company Acme, performance is actually suffering because they have this different type of an account, and we were then able to drill in and fix those type of issues. As we went through this journey, there was a couple things that we saw, little nuances or whatever you would like to call it, that we addressed. So for example, it's a sampling, right? And if you have errors, your errors aren't going to necessarily show up in X-Ray. So to increase the probability of it showing up in X-Ray, they have an API called force sampling of current segment. Also in AWS Lambda, you cannot get the root segment and add annotations and metadata to it. You have to create a root subsegment and then add annotations and metadata to that. Also, some services, for example, DynamoDB, is not going to issue its own subsegment or own segment for you. Instead, what the SDK does for you is create an inferred segment. So you won't necessarily be able to see the latency, the network latency from your Lambda to that DynamoDB. But for example, S3 will issue its own segment. So you'll be able to get a better idea of how much time is spent where. So very quickly, I'm just going to go through one of my little dummy apps and go through some of the things that I just talked about and some of the gotchas that we found. Yep. All right. There we go. Okay, so like I said, 10, 15 minutes tops, you can get something going. So first things first, you have to go to your CloudFormation. That was also released in the summer that you could flip that with CloudFormation. And you have to do a couple things. You have to give rights to your Lambda to be able to put to X-Ray. And here I'm using managed policies. Obviously, you shouldn't do that. You really should have, your put XYZ element OP. But for this demo, we're going to use the managed policies. You also need to then, just as simple as going to your function and adding tracing config and setting the mode to active. The difference between active and passive, the default is passive, I didn't mention that, is basically if another Lambda calls your Lambda and it's passive, then it's going to send a segment for all the work that it did. But if it's passive and you call that Lambda directly, it's not going to send a segment. If it's active, then anytime, whether you call it directly or another Lambda calls it directly, it will send a segment up to X-Ray. Another nuance that it's important to note is that IAM is a global service, and if you have an existing stack, right, and you go and you add this policy for X-Ray write-only access, for example, it's not going to update immediately. It's not going to replicate to all the different regions immediately. And when CloudFormation goes and updates your Lambda and says tracing config is on now, it's going to go check for that policy and not find it, 9 times out of 10. So as silly as it may sound, all you really have to do is rename your policy. And what will happen is instead of updating an existing role, it will create a new role, and that will return when it has been replicated to all the regions. And then therefore, when you go and update your Lambda with tracing config on, it finds the policy updated. Quite a few of our teams spent a lot of time on this, so hopefully I can save you a few moments of stress. All right, so then the very next thing you do is adding the X-Ray recorder, the core AWS SDK, and the SDK instrumenter. And theoretically, you can step away and say you're done, and you're going to get data. At this point, your Lambda itself will send a segment, any downstream resources will send a segment, and you'll have information, and that's great. But there's so much more you can do. So you can, like we mentioned earlier, you can create custom sub-segments. And for example, like I said, we have, let's say, a Monte Carlo simulation, and just before that simulation, we can create a new segment and sub-segment, sorry, and get that information. So my dummy app is image resize. So what I did was, on my very important workload, I created this sub-segment called resize image, and then if there's an exception thrown, I add it to the sub-segment, and then once we're done, we end this segment, sub-segment. The other thing I mentioned before about the dummy root sub-segment, so as soon as I start my service, I create a root subsegment. I add any metadata or annotation that I would like to then turn around and search on. And that's pretty much it in terms of code. There really isn't too much work to do there. And so then we come and we look at our dashboard. And like you saw earlier, you can see the color distinguish. When it's yellow, that means there's an error. When it's green, that means everything's fine and dandy. And you can kind of see what the average transaction per minute is, what your latency and such is. So for example, let's see, we have an error here. So I can click on this checkbox and I can say view traces and go to those errors. And because I'm afraid that I might have been logged out, I'm just gonna tab over here and you can see it there. So we see here right away, we have an exclamation point, we have this red one, and that is our root cause. So when it went to validate our image, we see this subsegment here. It said, okay, what is the problem? We can click on it and right away see a full stack trace of what exactly happened. We can also add, in that catch block that you saw earlier, I could have then added more metadata, like what my payload request was, so that I can turn around and then replay that same thing. And see, okay, well, the issue here was it's skipping a non-image. I uploaded a CSV file instead of an image. The other thing you can see is, like, for example, this dummy app that I have here is an event, an S3 event. You upload an image, it does something, and so on. And you can see that this also ended in error. And it tried one time, it tried to solve it. It did another time, it tried to solve it. A third time, and it still couldn't solve it, and it gave up. And I can see all 3 attempts, and again, click on that exclamation point and see what's the issue. And so the error I got is unable to infer image type. So that is that error handling. And then the last thing is, okay, a successful use case. And so we can see here that in this one, this was a cold startup time. You can see initialization. Here it took 138 milliseconds, not too bad. My whole resize took 2.6 seconds, kind of slow. I'm sure there's a lot I can do to improve that. You can see validate image, no time, no big deal. S3, it took 1.2 seconds. That's quite a bit. Maybe I can, change regions and that sort of thing to see if that changes. Then the resize itself took almost a second, and so on. We can click on my Uber, my root subsegment, and we can see some of the annotations. And being a fintech company, this image processing server includes your bank and your employer. So we have banker, Acme Bank, and employer, Acme Company. And we can also search on that. So for example, I can say, go view traces, and I can go and say, okay, show me all the bankers. And because I only did one bank, we have only one result. But theoretically, you could see how you would have a wide set. And then you can search on that and say, well, you know what, for Acme Bank, it took 1.6 seconds. But what employers are under this banker? And then we can see, okay, well, Acme Bank has Acme Company under it. And you could see how, like what we did in production is different companies would have different response times depending on the type of accounts that they had. So that's pretty the bulk of what I wanted to show you. It really was pretty straightforward and easy to implement this and gather information and be able to act on that data for us. Very little effort, like I mentioned, latency across different resources, downstream resources, and then be able to slice and dice your reports with annotations. Thank you much for your time.
Thanks. Cool. Thanks, Yvonne. It's always great to hear customers when they talk about how they use our tools in AWS. This is great to see. Quick. Okay, so as a quick recap, right? So we talked about a lot of things today. I think the key takeaways for you is this. Right? When you build a serverless app, you have a lot of tools that are built in that by natively are built in and integrated with LAMBDA and serverless services that you can use to do logging and monitoring. You can add metrics. You can do alarming on those. And you have, with CloudWatch metrics and Elasticsearch and other third-party tools, you have the ability to easily extend those. So if you run into any debugging situations, you can always add these things, and you can aggregate things, and as we showed earlier. And then X-Ray is a powerful tool that lets you visualize, pinpoint, and troubleshoot issues. It lets you filter, you can search, and then troubleshoot and fix issues. As Yvonne said, it doesn't take a lot to get it integrated into your app and then to be able to troubleshoot and fix issues as well. Cool. All right, thanks for your time here. And hope you enjoy the rest of your time here at reInvent. Thank you.